Okay, today we're going to focus on naming molecules. So some of the things that we've talked about when we did covalent bonding. So we've already practiced doing ionic compound naming, that type of nomenclature. And now we're going to look at some of these molecules, and we're going to also practice naming a few of the acids. So we will take a look at how to write the formula from the name, and then writing the name given a formula. So both ways. All right, so here are a list of prefixes that you'll want to know. This is in Chapter 9, Section 2. So if you have your book, I would flip open to that section. I believe this is on the first or second page of that section. There is a chart with these prefixes, and you'll want to have that out so you don't get confused as we are moving through some of these naming procedures. So as you do that, these prefixes basically go in front of each of our element names that we use when we are identifying or naming a compound. So each of these prefixes corresponds to the number of atoms that I have in my compound. And this will always come before each name. So the element that I list first and the element that I list second in my name. So again, have your book open so you can see this chart. You want to have that in front of you. This is Chapter 9, Section 2. Okay, if you've already done that, then here are some of our naming rules. So go ahead and summarize this into your own words and write these rules down. You'll want to know these when we're naming molecule compounds, covalently bonded stuff. So I'll give you a second to do that. Okay, so let's take a look at these rules. When I name a molecule, I have an element that's listed first in the formula, or the name, and then I have an element that's listed second. So it just corresponds to how it's listed in the formula. So if I look at my formula, if I have an element that's listed first, that's the element that I name first, and whatever is listed second gets named second. Now there are a few things you have to keep track of. However many elements are listed or indicated by your formula, make sure that you look at put the prefix, the corresponding prefix in front of that element name, and you list the entire element name as it's given on the periodic table. The second element that is listed in your name, which corresponds to the second element that's listed in the formula. So the only exception here, obviously we have to put the prefix in front of the word to indicate how many of that atom we have, or that element. But then we also have to put this "-ide" suffix at the end. So for example, if I had 2 chlorine atoms or ions in a covalently bonded molecule, I would say dichloride. Di indicating there would be 2, that's the prefix. Ide indicating it's not chlorine as the atom, but ide as an ion. Step 3 just tells us that we have to make sure we put in those prefixes like I just indicated, and there are a couple of linguistic kind of formatting type things you'll want to think about when you do that. One rule that we do is we never put mono in front of the first element. So if there's one element there and we just list the element name, we can assume that there's only one. So we don't put mono in front of that. The other thing we don't do is attach mono to oxide in this way. So if you had one oxygen atom in your compound, and if that was listed second, you would put the "-ide" on the end. But if you only had one, this looks and sounds kind of funny when we say it. So this would be monoxide, or however you want to pronounce the double O. So what we do for just pronunciation's sake, we don't include this O right here. So when you attach the mono prefix, you're eliminating that O when you do it for an oxygen or an oxide. So this would be monoxide, kind of like carbon monoxide, the stuff you don't want in your house. Okay, so let's look at a couple of examples. If I give you the formula for a covalently bonded thing, you should make sure that you can write the name. So you just have to look at each element that is listed, and you have phosphorus here in the beginning, and then oxygen is the second element, and then you just need to look at how many of those you are given. And for phosphorus, I have 2 atoms, and for oxygen, I have 5. So we just attach the prefixes that correspond to those numbers in front of each of the element names. So I should get diphosphorus. There are 2 of those, so I say the whole element name for the first guy. And then oxygen gets shortened to oxide, and I have 5 of those. So I should have diphosphorus pentoxide. And pent is another one of those syllables, or sorry, prefixes where we eliminate the A at the end. Instead of saying pentaoxide, that sounds a bit funny, so we say pentoxide instead. So let's look at the second one. I have sulfur and an oxygen. I have 1 sulfur. We do not put mono in front of the first element, so I just name that as sulfur. And then here we have 2 oxygens, so we should say sulfur dioxide. Okay, di indicating 2, oxide is the element that we've got, oxygen. So I'll give you kind of a second to catch up and make sure you have this written down. And then the next thing we'll do is look at writing the formula from the name. And we'll see if my pen works to do that. Okay. So let's take a look. We've got dinitrogen monoxide. That is laughing gas, actually, the stuff you get at the dentist. Now, you have to look at the first thing. Let's break this apart. We have di, which means 2, and then nitrogen, which is the element nitrogen. So the first part of your formula should be N2. 2 is subscripted. And then we have mono, or mon, to indicate we have 1 oxygen. So our formula should be N2O. Di means 2, and then mon means 1. So N2O. So that's fairly basic as long as you know what these prefixes mean, and then you can write the elements directly down and then put the numbers as a subscript. We don't have to indicate a 1 here. That's always assumed. If there's no number listed, we assume it's 1. So let's go ahead and look at some acids. So you'll want to write down these couple of things here in red, and then we'll look at 2 examples. Okay, so when we name an acid is anything that will produce a hydrogen ion, usually H+, so hydrogen with a +1 charge, in a solution. So if I mix something in water, usually, I can produce an acid. So what we're going to deal with is binary acid. So it contains a hydrogen and then 1 other element. So the prefix always, since we have hydrogen, we put the prefix hydro, and then we attach a suffix of -ic at the end of our second element name. So whatever that hydrogen is bonding with in the acid, we replace with -ic instead of "ide" this time for an acid. So hydrofluoric acid is HF, and HF will actually eat through your bones, so it's pretty nasty stuff. But you look at the H, if this is an acid, you put hydro, and then fluoric. Make sure it's FLU. Remember, flu. If you drink fluorine, you'll get sick. So you get the flu, I guess. So this would be hydrofluoric acid. This over here, we don't have to do anything with the numbers or the amount of atoms that we have. So no prefixes like we had for the binary molecules. I just have to know this is hydrogen, so I put hydro, and then this is phosphorus, so I say phosphor, and instead of the us, I attach an ic at the end. So this would be hydrophosphoric acid. So that's fairly simple if we just have a hydrogen attached to one other thing. And again, no prefixes for the amount, just attaching an ic at the end of the other element that hydrogen bonds with, so you get one big word for your acid. All right, let's look at oxyacids. So go ahead and write down steps 1 through 4. An oxyacid is any type of acid that contains an oxygen in it, hence the oxy part of the oxyacid name. And excuse this typo here, it should be gets dropped altogether. Slip of the finger there for that. Okay, so let's look at these two examples here at the bottom. When you see an oxygen in an acid, you do not need to name hydrogen in that acid at all. So there's no hydro part. What we end up doing is just naming the polyatomic ion that we see here. So you should refer to your list or from memory. If I look at this example, this is HNO3. So since there's an oxygen, I know that it's an oxyacid. And then I ignored the hydrogen, so I'm really worried about naming just this part. So this is the nitrate ion. So I look at my rules. 8 will get replaced with ic. Okay. So we stick that on the end instead. So nitrate becomes nitric, and then I have nitric acid. Also not such good stuff, pretty bad. Same thing over here. If I have hydrogen bonded with nitrogen and 2 oxygens, I know there's an oxygen, so I drop the hydrogen from the name, don't need to worry about that. And then I have nitrate ion, so ite gets replaced with us, so then I get nitrous acid. So that's also pretty simple as long as you know your polyatomic ion names. And then you just replace, remember 8 gets an ic and ite gets an us instead. So let's go ahead and name from the formula. Okay, so we're going to look at 2 examples. We're going to write out the formula for these. So my first one, hydrobromic acid, so there's no oxygen in here because I have hydro or hydrogen named. So I know in my formula I'm going to have a hydrogen. So then I also know that I have whatever bromic, which would refer to bromide or bromine. So I know I have these 2 things, and then you need to do your crisscrossing from your charges. So hydrogen will get a +1. It's in group 1 somewhat, and with acids, hydrogen will always take on a +1. Bromic or bromine, bromide is a -1. It's in group 7, so it picks up 1 electron, giving it a -1 charge. If you crisscross the charges then, listing the hydrogen first, you will sorry about that, you will get HBr for your formula. Okay, so that's just crisscrossing the ones for each of those charges. Now, if I have phosphoric, I haven't named the hydrogen out front, so I know it must be one of my oxyacids. So if there's an ick at the end, I replace that with 8. So that tells me I have phosphate ion, which is a -3, and hydrogen is a +1. So if I crisscross those charges, this will be my overall formula. 3 hydrogens and 1 phosphate.